Good morning, students. Hope you all are fine. Today I am going to start chapter 1, rational number. Before starting this chapter, let us learn some definition which you already studied in your previous classes. First definition is your natural number. What are natural numbers? You everybody know these are the counting numbers such as 1, 2, 3, 4, 5. These are called natural number. Second is whole numbers. What are whole numbers? The natural numbers together with the number 0 such as 0, 1, 2, 3. These all numbers form a whole numbers. And third definition is integers. All natural numbers including 0 and negative of natural number such as -3, -2, -1, 0, 1, 2, 3. These numbers include both positive number as well as negative number. These are called integer. Next is rational numbers. Very important definition. A number which is of the form P over Q, where P and Q are both integers and the denominator Q, it is not equal to 0. It is called rational number. For example, 1 over 2, 3 over 5, etc. Now, what are positive rational number? A rational number is said to be positive if its numerator as well as denominator are both of the same sign, that is either positive or negative. For example, 4 over 7 which have the same sign, plus plus, and -3, -11. These are all positive rational numbers. In a rational number, it is said to be negative if its numerator and denominator are of opposite sign. That is, if numerator is negative, then another one denominator is positive. For example, -1 over 3, 5 over -30. These are negative rational number. Now, next definition is standard form of a rational number. A rational number P over Q, it is said to be in standard form if P as well as Q are integers with no common divisor other than 1 and Q is also positive. For example, 3 over 6. You everybody know 3 over 6, they have a common factor 3, because when I cut 3 with 6, 3 ones are 3 and 3 to the 6, then it is converted into the standard form 1 over 2. So this is the standard form of a rational number. Before starting the exercise 1.1, let us discuss some properties of a rational number under addition and under subtraction. The first property is your closure property. In this property, sum of two rational number is always a rational number. That is, if A and B are two rational number, then their sum A plus B, which is a rational number. Let us take an example, 3 over 5 plus 1 over 5. By adding it, we will get 3 plus 1 over 5, that is 4 over 5, which is again a rational number. Under subtraction, the closure property says if A and B are two rational numbers, then their difference, that is A minus B, it is also a rational number. For example, 3 over 5 minus 1 over 5. And you everybody know the denominator here is a 5 and numerator 3 minus 1, 2 over 5, which is again a rational number. Now your next property under addition is commutative property. In this property, the sum of two rational numbers in any order remain the same. Now let us explain it by taking an example. For example, I will take A 3 over 5 and B 4 over 5. Now interchange its order. B, it is 4 over 5 and A is 3 over 5. When I take the LCM, the denominator is same, so I will get 5. 3 plus 4 and again here 5, 4 plus 3. 7 over 5 and it is 7 over 5. And you see now, when I change the order of two numbers, their after addition, their sum remains the same. But in case of subtraction, it is not so. When I change its order, their difference, it is not same. Now let us take the same example here also. Let us take A 3 over 5 and B 4 over 5. Now I will solve it. Now again B 4 over 5 minus 3 over 5. when I take their difference, you will see their answer is not the same. That is 3 minus 4 here, and here denominator is 5, 4 minus 3. 3 minus 4 is minus 1 over 5. And 4 minus 3, it is 1 over 5. This number is negative and this number is positive. So both are not equal. Left hand side here not equal to right hand side. So commutative property does not hold in case of a subtraction. The third property is associative property. In this property, the three rational numbers can be added while being paired in different ways. We will get the same result. But in case of subtraction, it is not so. When we subtracted by grouping them in different ways, we didn't get the same result. Now let us see how it is. I will explain it by taking some example. Let us take A 1 over 3, B 4 over 3 and C 5 over 3. You can take an example. Now put these values and I verify it. In the left hand side, A is 1 over 3, so I put here A 1 over 3, B I take 4 over 3 and C I take 5 over 3. Now putting the value, I will solve it. A again 1 over 3 plus B 4 over 3 and C is 5 over 3. First of all, I will solve this bracket by taking LCM. 4 plus 5, you will get 9 over 3. Again, you will take the LCM as the denominator is same. I will get 3 here and 1 plus 9 and its answer is 10 over 3. And in case of this, first of all, I will solve this bracket. The 3 here is the LCM and in the numerator, I will get 1 plus 4 and it is 5 over 3. Again 5 over 3. 3 is LCM and 5 plus 5, 10 over 3. Now you see here left hand side is equal to right hand side. So associative property holds under addition. But in case of subtraction, I again take the same numbers here. Now by putting the values, I will see A is 1 over 3 minus B 4 over 3 and C is 5 over 3. Here A is 1 over 3 and B is 4 over 3 and 5 over 3. First of all, I will solve this bracket. 1 over 3 remains same. In this bracket, 3 is LCM and 4 minus 5, it is minus 1. 4 minus 5 is minus 1 and minus minus, you everybody know it is plus. And 1 over 3 plus 1 over 3, it is 2 over 3. But in this case, right hand side, I will solve this bracket. First of all, the LCM is 3 and 1 minus 4 is in the numerator which I solve and I will get here minus 3 over 3. 4 minus 1 is 3 and you will put the sign of the greatest term, that is 4, and its sign is negative, so I put here negative sign. Now it is minus minus again plus. LCM is 3 minus 5 and minus 5, 6, 7, 8. It is minus 8 over 3. Now you see in the left hand side there is 2 over 3 and in the right hand side there is minus 8 over 3. Here left hand side is not equal to right hand side. So associative property does not hold in subtraction. Under addition, there are two important properties, that is property of 0 and another one is the negative of a number. Fourth one is your property of 0. According to this property, when 0 is added to any rational number, the result obtained is the same. That is, if A is any rational number, then A plus 0, or if you change its order, that is 0 plus A, you will always get the same result. For example, 2 over 3. When 2 over 3 is added to 0 or 0 is added to 2 over 3, you know everybody, the answer is the same, that is 2 over 3. So, 0 is called the additive identity for a rational number. Now, next is negative of a number. Everybody know negative of a number is what? That it is also known as additive inverse. See here, if P over Q is a rational number, then there must exist a negative now minus P over Q, which satisfy P over Q plus minus p over q equal to 0. Here, minus p over q is called a negative of a rational number. Now, let us explain by taking one example. For example, if I take one rational number 1 over 2, when I add it is in its negative number, that is minus 1 over 2, then what the result you will get? You will get always 0. So, what we conclude here, ki 1 over 2 and minus 1 over 2, both are negative of each other. That is, minus 1 over 2 is also known as additive inverse of 1 over